Okay, welcome to Swell Academy. Today we're looking at segment addition postulate, which basically tells you two smaller segments, AB plus BC, added together will equal a larger segment. So basically, if we add these two smaller segments together, they're going to equal this third larger segment. You know, it's an idea. If I travel from A to B and then B to C, my total distance will be AC. So let's look at this question here. DE, I always like to start by putting this like little formula plus EF is going to equal to DF. So in this case, DE is 6x plus 4x, and that's equal to 10. And then 10x is equal to 10 divided by 10. And that's telling me my value for x is 1. Now be careful, it's not asking what is x, it's asking what is EF. So I have to go to EF here and realize that EF is equal to 4x, and I have to do 4 times, well, that's a terrible one. 4 times 1, 4, and our answer here would be 4. Let's take a look at another one. This question could be presented in many different ways. One where they don't really list the values on the number line, but that's easy enough. You could just go to JK here and put the 5. I like to put the 5x minus 4 here. KL is 3x, and then the JL here is 4. I like to put this together. And then what I like to do is set up the JK plus the KL equal to the JL. And then I say, okay, I got the 5x minus 4 plus the 3x is equal to 4. Combine like terms. 8x minus 4 is equal to 4. Move my numbers to one side. These little algebra terms I like to use. Sorry about the chainsaw in the back. Decided to make a video and someone decided to cut down a tree. That happens. Just keep working. So we get x equals 1. The 8 is multiplying to the x, so I divided both sides by 8. I get x equals 1. But I'm always aware of what are they asking for. They're asking for JK. JK is 5x minus 4. I want to plug in that 1 I got for x. 5 minus 4, my answer here is 1. That's a good one.
Okay, another good problem here, and it actually gives us an opportunity to work with a little, you'll see decimals, but same setup where we're plugging in our values for, the given in the given statement here. VW is 3x, and then UW here to here is 7x minus 7. And then we're going to set up our little UV plus, let's make sure that looks like a V, plus VW is U. We'll make sure that looks like a U too. UW, I like it like that. Okay, that's good. And then we have x plus 9 plus 3x is equal to 7x minus 7. We're going to combine like terms. 4x plus 9 is equal to 7x minus 7. We're going to move letters to one side, and I'm going to move to the right because I want to make sure x stays positive. If I move, let's just put the letters here. If I move to the left, right, I have to balance my equation. I got to put letters on one side, numbers on the other. I would end up with a negative 4x here. I don't want a negative number for my variable. I want to try to keep it positive. So I'm going to move to the right here. And then I'll move to the left with my numbers. Plus 7, 16 is equal to 3x. Divide by 3. X is equal to 16 divided by 3 is 5.3. So simply you're just well, they want you to simplify your write as a proper fraction, mixed number, or integer. So actually, in this case, the decimal is out of the picture. So we got to stick with that 16 over 3. And if they're plugging into 7x minus 7, there's going to be some fraction work we got to put together here. So we're plugging in this 16 over 3 to UW. That's what they want. They want UW. So we're going to go 16 over 3, that's x, minus 7. And then we get 7 times, so we're just going to basically make this a 7 over 1, and we're going to multiply 7 times 16 and get 112, and 1 times 3, 3. So basically I just multiplied across here, minus 7. Now I cannot add or subtract these because these are not the same size pieces. So what I need to do is actually find a common denominator with 3 and 1. So let's just, oh, that didn't work. Let's just move this over here, give us a little space. Yeah, that's okay. And let's convert these fractions. So I have 112 over 3, and I want to change it to a denominator over 3, and I have 7 over 1, and I want to change it to the denominator over 3. So if I multiply by 1, I get 3. So this one fraction basically stays the same. Here, I need to multiply by 3 on the bottom, and if I do that on the bottom and I want to keep it to the same, I need to do it on the top. So my two new fractions are 112 over 3 minus 21 over 3. I'm only going to subtract the tops. You never add or subtract your denominators. And you end up with 91 over 3. So you could put this, they want a proper fraction, so you could put this, or you could do 91 divided by 3, get 30, and then 30 and 1/3. This would be what we would call a mixed number here. Here's your mixed number. Actually, and this is an improper fraction because you have the number on top bigger than the number on the bottom. So technically you can't use this either. So no decimal here, no improper fraction, right? So actually we have to use this mixed number here. So you have to see what they give you in this box to fill in that 30 and 1/3 here. And then another problem we're looking at, this one, remember geometry is drawing. So on a line segment, I'm immediately looking at this and I want to say, and I don't even care where D is as long as it's in between C and E. This needs to be drawn properly. D needs to be in between C and E. If this doesn't happen, this drawing does not happen, then the rest of this problem can tend to be confusing at first, and it's not going to organize what's being given to you. Now I see it, okay, CD is 10, DE is x plus 15, and CE is 4x plus 2. And then I could take CD plus DE equal to CE. And then I have 10 plus x plus 15 is equal to 4x plus 2. Combine like terms, so I'm going to combine my numbers. X plus 25 is equal to 4x plus 2. I'm going to move my letters to one side. Minus x, minus x. I'm going to move my numbers to the other. So I'll go left with my numbers. And then I get, and I'm glad this is giving me another fraction here because I think it's important that we take another look at fractions because I think that's going to really challenge a lot of us, but we could get through it here. So here we have a 3x, 2 minus 2, 25 minus 2 is 23, and then these cancel out, so I have 3x is equal to 23. So let me take you through this. First of all, we can't do just both sides divided by 3 and say, okay, 25 divided by 3 is 7.6. We can't use this because it's a decimal. So we have to actually use this improper fraction, right? An improper fraction, just to go over it one more time, is one where the number on the top is bigger than the number on the bottom. A proper fraction would look like 2 over 3, where the top number is actually smaller than the bottom number. The numerator is smaller than the denominator in this case. Now, they want us to look at CE, right? We're over here. What is CE? CE, we know, is 4x plus 2. We know our x is 23 over 3 plus 2. So first thing we have to do is multiply 4 over 1 times 23 over 3. And we get, well, you get 4 times 20 is 80, 4 times 3 is 92. So we'll get 4 times 23, and we get 92 over 3. Then we take the 92 over 3 and we add 2 to it, or 2 over 1. Now we have to change this 2 over 1 fraction. So I'm actually I'm gonna warp this to the next page. Right? So we got the 92 over 3 plus 2 over 1. This way we don't run out of space here. And I need to change these fractions to have 3 as a denominator. The 92 over 3 and the 2 over 1. Now there's no change here because I'm just multiplying top and bottom by 1. There is a change here because I'm multiplying top and bottom by 3. So I actually end up with 6 over 3. And then I take this new fraction and I add the tops, not the bottoms, and I end up with 98 over 3. And then 3 goes, what I'll do is I'll look at it like this. 98 divided by 3, so 3 goes into 9 3 times, minus 9, I get to 8. 3 goes into 8 twice, 6, and I get this remainder of 2. So I get 32 remainder 2, and basically what that's saying is 3 goes into 98 32 times, and there's 2/3 of a whole left over. And this is our mixed number that we need to use, because remember, we can't use this improper fraction. We have to change it to a mixed number. And probably what they'll have is they'll have something that looks like this, right? And you have to put the 32 in here, you have to put the 2 here and the 3 here, and that'll be your mixed number to use. I hope this helps. The more you fail, the more you succeed. Make sure you look at your mistakes when they're made, and you go back and you approach it in a better way.